Hello, and welcome to our video on the website Geogebra. The first section of this video will be dedicated to looking at the graphing calculator and many of the unique tools that this website has to offer. In particular, we will demonstrate some specific affordances we found on this website, which is the affordance of how many different functions we can visualize with this tool. So first, I'm going to type in a simple function that you can graph on GeoGebra that you cannot graph on a typical TI-84 graphing calculator. And that is something that is not of the form y equals. So for example, we will draw a circle. So for a circle, we will look at something like giving it a radius, which will give it a radius of 3 squared equals x squared plus y squared. So to look at a typical circle, you cannot draw this on a TI-84 because it's not of the form y equals. And then some things that a graphing calculator can do, like graphing polar functions or parametric functions, which we also can do on GeoGebra, and I have drawn here in blue and in yellow. These are polar functions and parametric functions respectively. And while you can draw these on a typical TI-84 graphing calculator, you cannot look at them simultaneously while looking at something that is Cartesian, like what we made first. And then lastly, the last function type that we have drawn is a piecewise function, something that you can imagine while using a TI-84 graphing calculator by just drawing two functions. Here we can actually create one specifically. So we were talking about affordances. The affordances of this website is being able to view all of these function types at the same time, whereas you cannot do that on a TI-84 graphing calculator. And just being able to draw some functions that you can't even draw at all on a TI-84 graphing calculator. And while simply looking at graph shapes, normal graphs like x squared or e to the x or something like that would just be a substitution of this tool when talking about the SAMR model. If teachers use the different tools that GeoGebra has to offer, then they can change the activity more greatly. Students looking at piecewise functions could be considered an augmentation. While you can kind of do that with a TI-84 graphing calculator, you can't 100% do it in the same way that you can do it on GeoGebra. But looking at something like Cartesian functions, polar functions, and parametric functions all at the same time would greatly alter an activity, which would be considered a modification. The graphing calculator enables students to engage in self-regulated learning. Using this tool, students can make discoveries on their own while playing around with algebraic visualizations.
So now we will focus on the geometry tools in GeoGebra. Let's switch over to the geometry calculator by clicking the top next to the GeoGebra logo, which will show us 5 different calculators we can choose from, which is another key feature of GeoGebra for some advanced classes. So let's select geometry. The idea behind this geometry calculator is that users can create geometric objects like points, circles, polygons, etc., and use these varying features to further observe and analyze these objects. So on the left there are 2 tabs, so we can pick either algebra or tools. So let's use the tools tab. So these are simple tools, and if you want to see more, you can click on more and it'll expand showing you more features. So let's start by making a polygon by either going to basic or going down to polygons. You see here how it's different with regular polygon. I'll just do polygon. So I'll make triangle ABC. As we can see, the tools are organized based on their topic or use. Like we see many sections where we construct a multitude of different geometric objects. I'll go ahead and make a line. For example, there's a measure section where you can, a measure section where you can get the measurement of certain objects. So, BC, and a transform section where you can perform transformations on figures. So since we have a line and a triangle, let's reflect. So I'll select triangle, line, And as we can see, this format encourages a lot of exploration with just the expansive functions it includes. And we see that this is a general example if we get rid of the measurements on the sides. But we can make this specific by showing the axes and adding back the grid lines so students can see this on the coordinate plane. So users can either work with general examples or specific ones depending on their choice of representation. So some affordances of GeoGebra is that it attempts to be accessible to users by providing help links for all features with directions for how to use each function. As we see here, it'll do a little pop-up of help, and it will take you somewhere where it will describe in further detail. Another affordance is that these features are interactive, where users can input different commands based on what they want to investigate from constructed diagrams, which promotes deeper understanding and using these diagrams for investigations. To go into some constraints of these features, the effective use of this platform is very dependent on the student's fluency and patience in navigating specific tools, as there is such an expansive list of features that users may get lost or not use certain key functions. These features also promote self-regulated learning, and that students can explore mathematical visualizations in the form of diagrams and graphs independently, by which they can organize and manage their learning independently in an efficient and effective manner. In relation to the SAMR framework mentioned before, features would be considered an augmentation, as users could ideally construct these objects themselves with rulers or compasses, but this allows for quick and easy input and representations of these figures, so users are able to create these figures efficiently.
Now, let's explore the other math resources that GeoGebra has to offer and learn how we can use them in the classroom. Before we do that, make sure you are signed in with your account. I'm going to use Google Classroom in my case. From here, I'm going to click on GeoGebra icon and press on Math Resources. As you go down, you will see the different units of mathematics. Select your desired unit. In this case, I'm going to select geometry as an example. As you can see, there are multiple topics for every school grade, and you could select from any of them based on the focus of your lesson or desired topic of practice. I'm going to select from the middle school section the topic on angles. As you scroll down, we can observe the subtopics and different focuses within the topic of angles. There are multiple ready-to-use resources for students to explore and practice. Let's look at identifying parts of an angle. From here, you can also explore the student preview of the activity if you wish. GeoGebra has the affordance of being a suitable teaching resource to improve students' engagement and achievement in selected topics of mathematics for grades 4 to 12. However, one of its challenges of using GeoGebra is that it requires students to have some technology fluency to navigate the software. One of its limitations is that GeoGebra will mostly require an internet connection. If you wish to edit the activity, you can go to the upper left and press on the three dots and click on Copy Activity. You can edit each section of the activity by clicking on the pencil icon on the upper left. If you wish to add an additional element, click on this button and it will give you multiple options to add an additional resource. The level of modification from the SMR model can be described using this GeoGebra, as it allows for task redesign, moving beyond what is possible with traditional methods. For example, students can construct shapes, create angles, and experiment with geometry transformations. When you finish editing, you can click on Save and Close. You will be directed to the main page and go to your profile. look for your recent interactive resource. I'm going to select on the first one. And if you want to share your lesson with students, you have two options. You can either share it with your Google Classroom or Geogebra Classroom. If you wish to share it with Geogebra Classroom, you have to create a lesson title and click Create. You can let your students join the interactive lesson with the link or code displayed on top. A connection with the educational psychology comes with this assessment, as a student can self-assess their skills with self-checking exercises, and teachers can also create and distribute assignments to assess students and monitor their progress in real time. As the students submit their solutions, you can see their results instantly. And this concludes briefly how you can implement GeoGebra in your secondary math lessons. Thank you.